So today we'll continue with the fundamentals of data, and so we will look into little more aspects of data. So can you tell me what is a data set? Have you heard the term data set anytime? What do you understand by the term data set? Can any of you tell me? Prajakta, can you tell me what do you understand by the term set, subset, data set?
Hello.
Yeah, Prajakta, I can hear you.
Yes, sir. Means I know actually data is the collection of information, and data set means actually I can't say properly.
Okay. How about Priscilla? What is data set according to you?
So, a collection of data.
Okay. Example?
Example.
Your table, the records that you store in the table is like your data set, right? It is a collection of data. Each record in your table is like one piece of data. In that one record you have different fields and different values, but that is one record. So one record becomes one piece of data, one data structure, you can say. So, and then you have many records, means you are making a set, and ideally when you're querying, you're actually getting a set of data values from the superset. So I'm assuming you'll have done set, supersets, that kind of in mathematics. So it comes from there. So it is not very complicated to understand what is a data set. So here it says a data set is a collection or a set made up of some data values. So data values means there has to be some value, right? I cannot just say employee. I need to, if I say employee, then what data value are we talking about? Are we talking about name? Are we talking about profession? So now once we have data values attached to some data, then or some attribute or data attribute, then the next question is, where do we store them, right? Storage is another aspect of your data problem. One is you have the data is getting generated, somebody is going in the browser typing something, but once you close the browser it can disappear, right? So data is existing there and inside the browser also. So it is but if you want to make sure that you can retrieve the data later, then you have to shift it to a permanent storage. So permanent storage could be your hard disk, your database, on the server. So the next line says the data set can be in structured format inside a table. That is what I told you. That is the table itself is like a collection, is a data set. And when you have multiple tables, that also can be considered as multiple data sets. And when you say at the database level, it is also a data set within which there is multiple data sets. So there is one set inside the other, so you can think of it that way. The data set can be also stored in semi-structured format inside a file. So when we talk about databases, we're talking about databases servers, or some kind of a software like MS SQL Server, Oracle Server, or maybe MySQL Server. But when we but it is not necessary the database. We use the particular software to store the data there. we can store it inside a file also, so whatever you type inside the file is also a data. So most widely used semi-structured format is JSON format and CSV format. So what you're seeing is this slide is following with some examples. So in the first example, we see I have defined kind of a names array. So array is again a collection of data values, and what all do we have in this array? We have John, we have Joe, and Joey. So ideally this would have been within quotes, so I don't think it will work either single quotes or double quotes. It will be like this. Is the screen clearly visible? Is it too small? Hello? Hello, are you there?
So I can see the chart screen.
You're not able to see the slides?
No. I'm not sure. Prajakta, are you able to see the slide screen?
Yes, I can see.
Okay, I think I may be having network issue. Okay.
Let me know when you can see the data set presentation. Are you able to read, Rasila?
Let me rejoin, so just give me a minute.
Okay.
It's actually raining in my end.
Okay.
And now I can see some.
Okay, so can you read what you're seeing?
Yeah, a data set is a collection / set made up of some data values. The data set can be in structured format, inside a table, or in semi-structured format inside a file. The most widely used semi-structured format is JSON / CSV. Example: a collection of names stored in an array structure inside a program. String names in a list, it's John, Joey, Joe, Joey. Example: a data set is a list of employees. Data structure in JSON format. In a dictionary, it's one John, Joey, plumber. Example: a data set is a set of temperature collected every minute by a sensor in CSV format. 23, 11, 30. The second is 24.5, 11.31. Third is 0.23, 11.32.
Okay. So here you are seeing three different examples of data values existing in different places. So that is what you need to understand. One is you have defined a variable called names inside a program. Now this particular variable is not alive, or these values are not alive unless the program is running. So, and once you shut the program or once you close the program, these values will disappear. So string names will disappear. There is no existence. So when we say it is existing, where it is existing? Can somebody, Priscilla or Prajakta, tell me, when the program is running, where does this variable value exist? Where is this data set existing?
So memory.
Very good. So whenever any program, there are basically two places the data can go. One is you can store it in your hard disk, which is a permanent storage. After you switch off the computer, the data does not disappear. You can retrieve it back. And one, it is either you are operating on this data. You don't want to make it a permanent storage, and it is in the memory. So all your programs, whether it is browser, whether it is any applications that are running on your boxes, they are constantly having data on both the ends. One is in the memory and one is in the database. So that is good, very good answer. And the second example is that now this is existing within the program, but the second set is existing probably in a JSON file, and JSON is the data is organized in a particular way, like there is open brace and small brace, and this is this square brackets, this is like one set of record, you can say. And then it may mean something, probably ideally you define JSON, you tag it with the attribute also, data attributes. So let me do I have the paper share. So ideally it's not like it will be without any attributes, it will be with some attribute. For example, if I want to create 3 records, let's say, you will have to see the exact syntax how it is, but it will be something like this, like let's say ID colon 1 comma name colon, within the quotes you have John, and let's say this is one record, and the other one will be ID colon 2, and name is equal to let's say Joe, and probably you have profession also, or let's say is employed, employment status, then you will say true. And then you have a third row, ID colon 3, name colon let's say Joey, and you have a profession, let's say, then the profession is, let's say, teacher. So here first of all I said there is a data attribute which is your ID, the name of the attribute is ID and name, and in this second case it is ID, name and employment status, and the third case is ID, name and profession. And what you're seeing on the other side is the values, the data values attached to the data attribute. So you need to remember this term, data attributes and data values. We assign values to the attributes. Now it is now why it is called semi-structured, means it is partly structured, means you are first of all you don't define what data set, what is going to contain in the data set. That depends on who is creating it. I must have written a Java program to create this file. So or there can be 2 different Java programs you are talking to, which will maybe in 2 different locations, and then you're combining the data from 2 different locations into one file, maybe, or maybe you're taking one file from all different sources and then splitting up. You can the point is the data in which fashion it comes, it is not defined. Semi-structured means it is not defined. Whereas if you are connecting to a SQL database, you have to create a table before you could use it. It has to be defined. So here the records are not defined over here. You can create your own table format or data set format. And also the thing is, it is not only that it is not defined, but it is not it does not has a fixed structure. So the advantage of the advantage is, let's say you want to monitor all the let's say cars running on the streets, and so what they do, they have the sensors and they keep sending you the IP address or location or something, and they may send it to you in particular format. So one company may be sending the ID and the location, but the other company will be probably instead of maybe sending the location, but it is using a different name for the data attribute. It may say it is ID colon place. So you could have data coming in from different sources at any given time. So the advantage of semi-structured is it will not give an error. It will accept any companies to send the data and in whatever structure they want. We can always tell them that we want it in this structure, it is preferable. But in an ever expanding customer base, you do not know which customer is generating the data. Data is not something is generated inside the database all by itself. The data is getting generated by the people, so some people are let's say Facebook has different types of data getting generated. At the higher level, definitely it's an image, or it is a text, or it is some number, or it is a some values. But as Facebook is expanding, Facebook took over Instagram. Now Instagram was generating some other set of data values earlier in some JSON format. Now when Facebook took over Instagram, that data also has to be pulled in. If I had a very fixed table, then I wouldn't have been able to integrate Instagram. So are you all understanding this, what I'm saying when I say a structured versus unstructured problem, semi-structured? And the advantage of semi-structured, in semi-structured the files and the data can come in any format. It is just a file, and that file I can attach it inside the browser and send it through the application, send it through my sensor. It is a simple small size file. So the size of the file can be 12 KB. So we are not talking about we are talking definitely about a lot of files, but each file will contain a small piece of data. So when you have this kind of small piece of data, it is also fast. So not only does not has a fixed structure, but the size of the file of the data is small. You don't have to send the entire records in one file. You may send 10 records at a time, which is small file. When you have a small set of data, it is easier to send across, and you can accept the data from any sources and any format. Till then they are following a JSON format. That is only condition. If I am expecting a JSON format, you make sure you tell me what is your attribute. At least I know what attribute I'm looking at, and if I will decide, my program will decide then what I need to do with that data. If the attribute is required, not required, throw an error, log it, do anything with that, all the processing work. So now this is a kind of a JSON format. How does the CSV format look like? CSV basically stands for comma separated value. So remember that term. CSV means comma separated values, but it is not necessary that it is separated by a comma. You can separate it by a colon also, and your program can be designed to understand that the data that is coming in is separated by comma. So let's say I'll create a notepad, a simple file. Again, this is not a structured database. It is coming in maybe it's coming in a it's a semi-structured format. So I can say I am sending a value of ID, comma, roll number 12, name, let's say I say Priscilla, and then I follow it on the next line, then 2, then 13, comma, Prajakta. So this kind of files, I can store it in the text file, or I can store it in the CSV file. If you open in any Excel file, any CSV file, it can be opened in Excel also, or it can be opened in spreadsheets also. But the thing is, there is a problem over here, right? If you send it in CSV format, how do I know what is the first value? What happens if you send some junk characters, like something like this? Like you send a apostrophe, my program will get confused, no? Or let's say there is a comma also in the data. How will you make sure that the comma is not considered? So all this there can be when you leave it free in CSV format, there is a little risk of the data coming in a corrupted format, and you are not able to use the data, and that's why JSON format is the most preferred format, because here you can you get the advantage of defining it like a table and records, so that is the advantage. So I think it is not the square brackets are outside, so you can see somewhere on the website what is the format of JSON format, exactly, and you can create your own JSON format. So you see, it starts with open bracket, open brace brackets, and if you have an array, I think you can use square brackets or something. So I hope you understand that JSON format versus CSV format. So can you explain now, Priscilla, what you understood so far? What is a data set? In what formats it can come in? What is the difference between JSON format and CSV format?
So a data set is a collection of data, like generally it can
Data
be about
values. Okay. So data
yeah,
can
collection
be,
of
we
data
may be
values.
talking about data attribute, we can be talking about metadata, we can be talking about data values. So we have to now we are getting more specific. Okay.
Yes, sir. So for example, like a particular company's list of employee information, their profession or their salary, that can be considered in a data set, or the rating of a movie rating review also can be considered in data set. And there are two types in which the data can be stored. Like one is like with regards to CSV. CSV is comma separated values, like with regards to Excel sheet, it can be considered it's a format. And then the second one is JSON. In JSON we will, as you had showed, like we will store it in the form of dictionary. We will pass the attributes along with its value.
Yeah, so JSON has an advantage of defining the data attribute also. It is much easier to express data value in terms of data attributes also, so that the programs can make a judgment. This is an ID, this is a name, this is a location. Because program is going to read the data, it has to separate out what are the attributes, what are the values, okay, what attribute we are into focus. The other term that which is seen over here on this slide is the data structure. Now when we say data structure, a JSON is a type of data structure. An array is a type of data structure. A data structure helps you to store the data, a collection of data, in a particular way. And this is a complex data structure, right? There is a structure within a structure. For each record there is one John electrician. That is like one data structure. But this is a collection of multiple data structures. So when you hear the term data structure, think of how the data is kind of presented to you. Is it presented in an array format? Is it presented in a JSON format? Is it presented in a CSV format? But mostly we are talking about data structures. We are talking about arrays, or so we look maybe list, or maybe a table, table object. So it can be stored in an object, right? So object is also kind of it has its own data elements inside an object, a class and an object. So object, so that also could be a way you can store data. So once you know that data is getting generated, what are the operations that can happen on the data? So on any data there can be 4 types of operations only. Either you're creating the data, or by typing something in the browser you're submitting the form. Then that is the time the data has got created when you submit the form. Data is trapped in a variable, and the moment the computer is still running and you are creating the data. Now the data can disappear unless you store it somewhere now. So you have to put it, you have to kind of, you can say, serialize it or store it somewhere into some proper location, so that you can bring it back again later. So either you're creating the data, either you're reading the data, or you want what you want to, tomorrow you come back, you want to see who all have submitted the form. So that is, you're reading the data. Updating means somebody is changing the data. So somebody is modifying something in the data. So data value was 1, now somebody went and said it is 2, or maybe you simply want to delete the data. And when you say delete, it could mean that you're just marking it a delete, or it's still existing in the database, or it could mean a permanent delete. But temporary delete means you are marking it inside, say taking that record, maybe just marking it or shifting it to some other place. You are not really deleting, because you really do not want to delete any records. So especially, let's say in a bank, you only store maybe last maybe last 3 years of data, or 5 years of data, or 10 years of data. You make that, whatever the business government policies, that you are going to store in the database only the last 10 years of data. But the bank has been there for 20 years. So then what are you going to do with those data? So those data, when we say, it is kind of a delete operation happening, but it is not a delete exactly. Ideally, what would happen, they would remove all the record, which is delete operation, but they would actually shifting. They'll shift it to an archive. And the archive will be a kind of a backup, or a low cost storage format. So when we say storage format, means hard disk is one type of storage format, right? Your pen drive is another type of storage format. You can be storing all your data in pen drive, or you could be storing you want to go with maybe a magnetic tape. A magnetic tape looks like a film roll, your movie film rolls, it looks like that. So because that is much cheaper, you can archive it. But to retrieve anything from a magnetic tape is much slower compared to retrieving something from a hard disk. So now we have technology, storage technology like SSD, solid state device. Now SSD is much faster. So you may want to store the data in SSD. You may store the data, all the data may be stored in a network of hard disk, maybe a network of storage devices. It's called the SAN, storage area network, where it is a collection of all the storage units. And there are so you can you have to simply tell, I want to store this in this particular storage unit. Your cloud, your drive services and everything, when you say I'm uploading a file to the drive, but there are a lot of people uploading a file to the drive. So is it only one machine serving you? No, there are many hard disks serving you at a time, but you do not know. From your perspective, you are just uploading to one location, which is a Google Drive. But Google Drive is very intelligent to connect to a network of devices, and as in where the storage is available, it will store over there. So so these are the 4 operations. So this can be asked in an interview, what is CRUD operations? These are the basic operations that happen on any data. Either you are creating the data, or reading the data, or updating the data, or deleting the data. Now in SQL, now when we talk about now you have to understand by now that we where this data is stored. Is it stored in a semi-structured file, or is it stored in a structured database? In a structured database, usually follows it is like mostly we're talking about RDBMS database. In structured database also there can be different type of databases, but we are mostly talking about RDBMS, which is relational database model system. So if there is a object oriented database management system, OODBMS, then that is not going to be, your data is not going to be available in the form of in the form of your tables and records and rows. No, it will be available in terms of objects. You are taking an object and you're storing an object and you're retrieving an object. That is how it works. There is no so if you want to search for any data there, it will be in a different way. So semi-structured files, when we are querying a semi-structured file, we have to do it in a different way. There's no we don't use SQL query there. We use different syntax which is more popular to connect to this semi-structured databases. So in SQL we are talking, so there is something known as, like, say, graphs. Graphs is like, it may be stored like a tree format. So have you all done graphs and binary trees in your course anytime? Linked list, binary tree. Project, have you done binary tree, linked list, etc.?
Yes, sir. Actually, I have studied in college timings
Okay.
2 to 3 years ago.
Okay. So the point I'm trying to make is data is not necessarily stored in RDBMS. It can be stored in JSON or CSV format. But again, your database can be stored in object-oriented files. Your objects are stored in a file. It is a binary data. You can the program can read the objects, the binary data, and kind of convert it into the object format. So data can be stored in object format, or it can be stored as a binary tree, which is again goes in the some file actually. And when it stores in the file, if you open the file in Notepad, it will see all kind of, it will look like a junk data, like just like we know in one class we opened a video file and it looked like a junk data, but it has to be interpreted. So so some libraries that you use can manage different types of databases. Now in this case we are talking about SQL query. I'm trying to give you an example that if you want to do these 4 operations, create, read, update and delete, what are the queries? So I believe you will have done databases, so this by now you are used to that there are 4 different types of queries, at the most basic level, right? Insert query, select query, update query and delete query. Your select query does not modify the data, but all the other 3 operations can modify the data. It can manipulate the data. We see, it means something is going to change once you fire the other 3 queries. So these queries are called data manipulation language queries, DML. Okay, you are manipulating something. And so if you have something like you're creating a database, you're creating you're creating some indexes, creating a view, stored procedure or trigger, those could be considered as DDL. So data definition language. You're defining something. You're saying the table will look like this, the record formats will be looking like this, the indexes will be on so and so field, the foreign key relationship will be so and so. So where is the page here? So what I was talking about, data manipulation language, manipulation queries. So somebody is saying data, these terms, then you have to be aware about it. If it is asked in the interview, what is DML and what is DDL, right? So DDL is used to define something. So in this DDL, you will anything that you are like you're creating, you create database, your create table, you create index, you create procedure, and if you want to change this, modify this database table, then you use alter statement, right? Alter table. And you can say I think to delete a database, I do not remember, but anyway, these are I think it's called purge database or something. So we'll have to look into it, what is exact query. But data manipulation queries, we are talking about which queries? The queries that modify, insert, update and delete only. Not select is not manipulating anything. It doesn't change the data. It just simply reads the data and leaves it. Okay. To do insert, update and delete is more expensive compared to, in the sense it will take more time. And because it takes more time, because when you're inserting a record, the database intelligently has to see whether this kind of records are allowed. Maybe you've not defined a primary key, maybe you're sending a null value. So there is data validation to be done, foreign key constraints to be looked into. So that is why it can take more time. But select as such is just reading the record and giving it to you. But again, if you are trying to read a very big set of data, it can the machine is busy trying to read the data, then somebody else, all your other queries will be in the queue. You cannot just keep on firing queries on the database and the database machine can handle. The machine can handle only one instruction at a time. ultimately all this language that we use, whether you're using a DML language, DDL language, it all gets converted into machine instructions, and machine instructions can be executed by one processor or a one core processor at a time. So you cannot do too many things at a time, and the processor has to be fast, or you have to use some parallel computing to do it faster. So but comparatively, what I'm trying to say, there is more work to be done when you're inserting, update and delete, because there is no checking to be done. It's like if you're getting into the airport, before you are kind of getting inserted into the airport lounge, you have to go to the security, and so that will take more time. So there's a lot of checking to be done to verify for the validity of the data. Any queries on this CRUD? Did you understand? Can you explain CRUD, Priscilla?
So CRUD operation are like there are 4 operations in it. The first one is it used to create a data. So when we actually enter insert query, when we use insert query, we can when we have to read the particular data, we will have to update the existing data. We will use update query, and when we have that particular data, we will use the delete query.
Okay. So now we move on to try to understand processing of the data. So processing of the data means something you are doing something with the data. Let's say for example, when you're cooking in the kitchen, you are getting all the ingredients. You are buying a vegetable, you're getting a salt, you're getting an oil. So those are like data values. But you want to cook a curry or you want to cook a rice, you have to go through a process. In that process, you're following some steps, and that maybe that steps are in a particular order. First you boil the water, then you put the thing. So it is like a pipeline of operations. So you are operating on the data. So that way, you can say this is kind of a data pipeline operations, or data processing operations, or data processing activities. So when we talk about data processing, these terms will come to may be in this data world. You will hear, oh, data has been analyzed, data has been transformed, data has been cleaned, data has been filtered, data has been sorted, data has been searched. So you are doing some operation on the data, just like in your cooking you are doing some activities, some processes over there, a set of processes. Here also you can you need to be aware that these are the data processing activities. Now this you will not find it in any particular book. This is I'm just written it down from my experience. Whenever I am dealing with the data, these terms come to my mind. So so you could be analyzing the data, transforming the data, cleaning the data, filtering, sorting, or searching. So what do you mean by when you say data has been analyzed, right? Hold on. When you say data is being analyzed, it says in this data process you're trying to derive some derivable result out of the existing group of data. This is a definition created by me. It's not there in any books. If you read something, some other book, you may find some other definition. But just to make it easier, I've created this definition. You're trying to derive something. So you're analyzing means the data is already existing. That is the first premise that you should know, that data is already existing, and now you want to analyze it. So when you analyze it, what is the kind of analysis you do? You say, I want to know the count of something, you want to know the sum of something, you want to know the total of something, you want to know who is the best ranker, who is the best performer, which is the best salesman person, so which virus has affected most of the people, which disease is the, there is always this we have the data. But now, what is the use of this data if it doesn't convert into some meaningful information? And that's why analysis comes into place. Let me do some analysis by looking at the data and how, and let me group the data. Let me see, what I can understand from the data. So so if you're deriving some value out of it, so at the end of the, when you derive, you're getting the output as on the right hand side, count is equal to 3. sum is equal to 7 and average is equal to 3.5. The right hand side never existed before you analyzed it. The left hand side is your input data, the right hand side is your output data. Then before it moved from input to output, or you can say the process, one particular step in the process, you are doing this analytical step where you are trying to derive some value, and that is this part of the process, you can say data is been analyzed. So example 1 is get a total count of all employees, or let's say example 2 is which country has the most sold fridge. So if you talk about to any in business world, depending on which domain you're in, the financial domain or medical domain, you will have this kind of questions saying I want to know this. There's a data I collected the temperature of, let's say, of my room through the day using the sensor. I stored it somewhere. Now I want to know which part of the day was hottest or which part of the day was cooler, and then make appropriate decisions on that. The second type of processing, it could be data is transformed. So when we say data is, so when you're talking about data analysis is always done on clean data. Means it is assumed that the data is clean by now. It is the data, expected input data, where I can begin my processing, where I can do my analysis. Analysis cannot be done on wrong data, unclean data, incomplete data, something like that. So now, but this step transformation is like a pre-step. Before creating the actual input, I am transforming it so that I can give this transformed data for further analysis. So let's say in machine learning we want everything to be numerical, or we don't accept true or false. There will be some conditions in which before anything is analyzed or used for meaningful analysis purpose, processing, meaningful purpose, you need to give a clean data. So you may have a requirement that you have to transform it. So transforming it is like, say, input data here A, B, C is one column, 1, 2, 4, true, false, true, and I'm saying this is not accepted. So what I do, I put a logic, I pull this data, which is actually called the kind of extract process, and then I transform the code. I change all this true, false, or true to, if true then change to 1, if false then change to 0. This is a transform part, and then I load whatever the output is into a second table, which is when we can say this is a transformed input data. Now the rows look like A, B, C, 1, 2, 4 and 1, 0, 1. This may be an acceptable format. So here this process can be seen as ETL. Okay, again this can be an interview question. What is an ETL process? So I hope you all are writing down everything, because this otherwise it will go away. ETL, or it will be ELT, depending on what is the first step done. So first step is extraction, which is pulling of the data. Pulls the data. Extract means pull the data. Once you pull the data, you have it, you transform it. Like change the data in a desired format. So at this step the data is still not in use. You have given the other data, but it has to be transformed, and load is basically store the data somewhere, the final data somewhere. So this question of what ETL is, so this transform you can do it in, there may be the software will enable you to do, say, create a ETL process, create an import process. So when you're doing an import process or export process, exporting the data to some other database, it will let you transform the data before you actually write it to the final database. So that also we can do. So the thing is, ETL process is very important. Let's say there are multiple data sources, it is coming. So this is another term, data source means the origin of data. So this data source can be, one can be on server 1 or location 1, or the second data source can be on server 2. So when you so not only this can be on different servers, so it can be in a different location. So when data is coming from different location, and you need a program to pull it, right? And this part of the program will be called as extraction program. And once you extraction program, then you have to apply some logic. Whatever data is coming from the extract process, you need to give it to the transform, and whatever output is coming from the transform, you need to give it to the load program. So you can think of this as 3 different programs. So when it is extracted, then it is transformed, and then it is loaded. It is finally you having a kind of your own database. It can be some data warehouse, or it can be some common staging database, you can say. These are the terms that could be used in your technical world. It can be a data warehouse, for analytical purpose or something. You can come out with some kind of a analytical queries. I said analytical queries means you're trying to find some some kind of derive some values based on this data. So you're getting a record. So let's say one example is you're getting from all the banks. In, let's say, Bank of India has many branches, it has many servers all across the country. Then you're pulling your extract program is pulling the data from all the banks for all the transactions that has happened for greater than 50,000. So that has been extracted, transformed. If you wanted to make it cleaner, in some kind of a transform format, will change the data. So it is loading is finally putting it in one place, and then you can fire queries to this data warehouse. So I hope you all understood what ETL is and what data has been transformed means. It is changing the data. This is one example of another change of data, where in the input you are getting 3 columns, A, B, D, 1 to 4, and true, false, true. But I don't want that first column for my work. So why should I collect the data? It is unnecessary, by increase in the data size. I have to store it, it travels over the network. So I remove the first column before I put it in the final database. So my transformed input data, the data is not changed, but some data has disappeared because I don't want it. I'm just taking the second column and the third column. So data can be transformed in even this fashion. What does cleaning means? So cleaning would mean that the input data that you sent, something is missing. You have sent a null value in this particular, you see the first row in the third column, there is a null value, and I cannot accept the data in this format. So what do? I can have some kind of a logic before I shift it. I say if there is no value passed, my Python program may read this file and say if there is no value passed, I will default it to false. So you have to come up with your own business logic to decide how to clean the data. So cleaning, this could mean providing some values or filling or let's say fill in the gaps. Wherever there is there's a blank in the data, you give some value which is accepted value. So here you're putting it to false, and now you having this data has been cleaned over here, one cell of the data, and that way you can have different rules and different logic applied on the data. So this process is happening, the cleaning the data. So I hope you understood the difference between transforming and cleaning. In transforming, you are changing the data, it is clean data, you assume it. But in cleaning, you are actually cleaning the data, you are creating some new data actually on the way, just to make sure the data is complete. If data cannot be cleaned for some reason, let's say you were expecting a full name but you did not get the last name, now how do you generate the last name? So what do you do with that? You have a choice then what to do. You can discard the data and put it in another database and send it back. So it doesn't even passes your, the process doesn't even take the data forward. You just pull the data which is okay, and the data that is not okay, return it back, store it in a log file, or send it, do anything with that. Your program will do the necessary. Data filtering. So what is data filtering? Filtering means you have a very clean data with you, and now but at a time, at any given instant, I want filtered data, in the sense I want only a set of records which is marked 1, or maybe I want a set of records which is marked 2, but at any given time I need that full set. So understand, filter is equal to subset of the data. So basically you have a set of data set of clean data, and then you are applying some subset, where you are saying I want all the set of data with value equal to 1 or column 2 is equal to 1, so you're creating a filter, so even in your spreadsheets, you can filter the data, right? You can say, I hope you have done this. So let's say subject. So I'm saying subject is maths, and then there are 2 rows maths over here, and then I have another row, say let's say physics, and then you have a name of the student. So name is X, Y, Z, A, B and C, and now you want to filter the data. So you need to be good with spreadsheets also, so we'll have a separate class on this also. So more filter, standard filter, let's say auto filter, what it does. Auto filter, do you want to use the first line to be used as a column header? So I say yes. That means now this magic works. So I can filter it by maths, or I can filter it by physics. But do I have the data? Yes. Is the data clean? Yes. And can I filter it now? Yes. So I have a filtered data. Now does it filtering of the data means the original data is gone? No. I can filter it out with using some other condition. That means I have a superset already existing behind the scene, and if I want all the data, I just mark it over here. So this is what is called data filtering data. You may be filtering an existing data set and pulling out a subset out of it. You may sort the data. So data has been sorted. Sorted means you are putting it in a particular order. So let's say I have this data over here. I again mark it over here, and let's say no, the thing is I want to sort, right? So sorting, I just want to sort this data. I don't want to sort the names, right? So data sort, and it is asking column A, do I want to sort in ascending order? I say yes. Order the column, I say no, I want to sort column B actually, and it has to be in ascending. I say no, it has to be in descending order. So column B means subject column will get sorted. So you see now the data has got sorted. Now what is the advantage of sorting? It is the biggest advantage of sorting is it is easier to search, right? So if it is sorted in descending order, if you are having P, something starting with P, that means you will not have something starting with Q later, because this is a descend order. So that way immediately if somebody is searching for, let's say, a subject called let's say maths, and let's say what do we say, let's say zoology, right? Let's say you're searching for a subject called zoology. If your first record is physics, that means zoology cannot exist over here, because this is a descending order, and that you were able to make this judgment because, or your program can know this by just reading the first record, the first alphabet, whether zoology will appear in the list, because it was sorted. So your sorting is usually done to organize, search. So when you say organize means what happens is, let's say I want to process this 6 records, or I want to process this 100 1000 records, and I want to, so I first of all I sort it out. Once I sort it out, I make a batch. I make a batch of 3 records. I split this one data set into 2 sets. One set will contain physics record, another set will contain maths record, and I will send it one set of records. I will say I want to know the marks for this, or I want to know something out of it. So I want to derive some value out of it. I want to do some analytical on this. So I can give it to this set of records to one machine, or one program, and I can give this set of records to another machine, or I can split my database using partitions. So partitions, or I want to say, or sharding, you can say sharding. So where I am taking one half of the database and putting it in one direction, and another half I am putting it in another direction. So this could be so partition and this term can be asked in the interview. It is all about splitting the data. So whether you're splitting column wise, I can say I just don't want I will take all the entire column and I will store it somewhere separately, and I can that way I have a lesser data size and I don't have my name in the data set. So I can create a data set using one column or two columns or maybe more columns as I desired, but I can split the data, and that is where partition and sharding will come into advantage over here. So I can create a partition using a partition key, something like that over here. So in this case the partition key would be subject, right? So based on if subject is equal to, I will split the data based on subject wise. So if the subject is physics, it will create one partition. If the subject is maths, it will be into another partition, and I can fire query on the partition instead of on the table. I can say select star from this, maybe this the name of this partition is physics partition, and the name of this partition is maths partition. So I can say select star from physics partition. So so this is something probably you have not covered in your colleges, but database is advanced, and we can work with partitions also, just like we work on tables. So you can give it these tables can be processed by different programs simultaneously, or different machines, so you can do anything with that. So but you can do this operations of splitting the data. So the idea, what I'm trying to tell you is, you are doing some processing of the data, and in this case you're doing sorting, and you're having the input data, but you cannot accept the data even though it is clean. You want it in a sorted format. So this is very important. So now we come to the data searching. Maybe you're searching the data. So what is the difference between filtering the data and searching the data? In data search, you may not have the original full set of data. You need to search through. It is like finding all the stones in the rice. So that is not called filtering, that is called searching. So you are basically going inside inside the rice, and then you're searching all the stones out of it, and then you're forming a data set of all stones. In this case I've given a very more like one of the complex examples where there is a PDF file name stored over here, and you want to read what are the values where this is probably the electricity bill, and you want to know which electricity bill has you want to know the electricity amount from it. So you have to take each record out, search for the amount, and then create a record of it, right? So you're creating a final data set which is not existing earlier, or maybe you need to search it through. So in this case the search is little different. Filtering is also kind of a search within a superset, but when you're talking about searching, means you're applying some algorithms. So here it is written, in this data process we're still trying to get a certain set of results, but initially we do not have any data, and slowly we build a data set based on some query or some algorithm. So we are talking about algorithm, means we are talking about program, and this is where your Python language will come into place, where you cannot just fire a query and things will be done for you. Maybe you have to write a program to do little code magic to give you a query results. And if it is a database, then we may use indexes to search faster. So indexes are nothing but sorted addresses. So let's say this is your this is your set of records. So if you have created, you can create an index, create an index on let's say subject field. So what is essentially happening is, when you run this kind of a command, another table is created, another table of what? Of the key itself. Here, so what are the let's add one more column, column over here and give it a actually if it is an index, ideally it should have some unique values, because indexing otherwise can be a problem. So let's say you are indexing let's say for now you are indexing it on ID field, your primary key. So it will create a table with a column name on which you have created an index. So you will see another table which you don't see actually. Database is doing it, this magic behind the scene. There will going to be another column which will give you the address. Now when we speak about address, we are talking about some location physically on the hard disk. Your you have to understand, where your hard disk is like a circular disk. It has got many rings, you can say, and there is one it is like a gramophone. The gramophone, the head is coming on the top, and it is reading the song, and it is definitely which part of where the head is, that data has been read over here. So in a hard disk also operates in the same way. So everything is in terms of concentric, let's say, circles, and it is also in kind of blocks. There's a block 1, block 2 over here, block 3 over here, block 4 over here, block 5. So your data is stored. It is not necessary now when you're storing the data, your record number 1 may be stored here, the record number 2 may be stored here, and the record number 3 may be stored here. Searching on a hard disk is difficult, but this process can become simpler if I say number 1 is on a concentric ring number 2 at location 5. It is like your GPS location, right? If you have the GPS location, you can quickly get to your 2 is in a concentric circle 2. Now I'm just giving a very user friendly name, but this will be ideally, the address will be in terms of block numbers or something, and record number 3 is in concentric circle 3, let's say, or let's say I give this circle number. I've given the same circle number here. This is in a different circle, right? So this can be said this is in circle number 1, record number 1. The record number 2 is in circle number 3, and location is 6 or 2. Now, so this is what you can say, this is a block address, and this is a key. This is a table of key and addresses. If you have defined another index on a table, another table will be created in the same way. So this can be block number 12, this can be block number 13, block number 15, this can be 89, this can be 1, this can be 2. So when you are searching an indexed database, what database is trying to do, it sees whether there are any indexes. It is searching, because how it will know how to search based on indexes, because it depends on a query. If you given a query like select star from my table where ID is equal to 6, it knows what you have given in the where clause, it knows you have given the ID field, and it also knows you have created an index of it, which means I can go and search ID 6 is stored at block number 2, and the search will happen faster. So that is what indexes mean. So indexes may be used to search faster. It may be stored in a binary tree format. So when you say binary tree format, binary tree is usually a sorted format. I hope you all have done binary tree. So binary tree means it is a kind of you can say a structure, a linked list structure. So a linked list structure always has a data value. You can has 2 sections or maybe maximum 3 sections, right? the middle section will always contain a value. Actually, in terms of class, this will look like class A. Class, let's say my node. So it is ultimately programming only. Previous node address, the data value at current address, and next node address. So you're storing these three pieces of information when you are ideally managing a linked list. Linked list is linking one data piece to another data piece. So what will this contain? Initially the first record, the previous there is no record, then this will be a null value. And if there is another record you have created, then you may have a value called so there is a value B over here, but how do you know which is the previous record? So that is where you store the address of the next record in the next node address. And so you store so let's say this is in block 1, right? And let's say this is in block 2. So here you are going to say the next record is in block 2 over here. And what you are going to store here, this is a previous record, means you are going to say this is in block 1. There is no previous record in the first record, that's why it is null over here. And in this case, again the next record maybe is, you are storing a value of C. So this is, you are storing a value of C in the block number 3. So block is like address on the hard disk. And so what is your storing? You're storing a value of a record called C. Now when I say this record, it may not only mean, it can be any data structure. As I said, it can be an array of structure, it can be a list, an employee record. So this can be itself, this central store value can be a complex data structure also. I'm just giving a simple data structure. So it can be a record in your table also. So what is going to be stored for previous node address, for for this, definitely the previous record is block 2, right? So block 2 is going to be stored over here. And what is going to be stored over here in block 2 as the next value? Block 3. So when it is stored means you're actually, it is stored as if it's a pointer, So the term pointer also means addresses. This fellow is pointing over here, this fellow is pointing over here. Then at the same time this is the next block, right? And this fellow is also pointing forward. So I hope this linked list is understood. So when you have a binary tree, it is also some kind of a linked list, you can say, but it is a sorted order. It's A is stored in one node, then A has the address of the next two nodes also, like B and Q over here. So this B, then C is stored over here, and D is stored over here. Diagram is getting a little difficult to draw. Means, so this one node you can think of this one node is this one piece, okay, one full set of record or values with the addresses. So it has a left value and it has a, you can say, a right value also, and this value has a left value and this value also has a right value. So now this is kind of if it is a binary tree, means there can be only 2 nodes at a given time. Now if you want to search for q, first you'll say search for whether you'll see on the left hand side. If it is b, that means it cannot, you don't have to search down, you have to just go on the right hand side and see if there is any other element. If there's q, means you found it. If you're searching for z, then you will go down this tree. There is x over here, let's say there's an x over here and there is a z over here. So so in a binary tree, how to which part of the tree, which nodes to traverse. So it is a simple program that by its so you need to do binary tree traversal. So that's why I said, when you're storing this kind of data, it will be stored in some file over here, and whenever your program should be able to read this file and create a tree out of it, and you should be able to use some logic to search the binary tree for particular records. So this kind of stuff is used in GraphQL, graph query language, or graph databases. So graph databases is mostly used where you want to store relationships between one object and another object. For example, there is a parent, and then you want to know which are the children's, and then children's children, and then you want to search this children is belonging to which generation. You can search also. So I hope you all have understood what searching does and what is the difference between searching and filtering. What is the difference between searching and filtering? Okay, so now that we have done this, so Prajakta, can you explain
Hello.
Yeah, can you explain what you understood? Was there any challenge in understanding?
Yes, sir. So actually, I understood most of the things. Means there are few activities to perform data processing. Means there are data analyze. Then we have to transfer the data. After that, we have to claim the data, and then filter the data, and sort the data, and search the data.
Okay. This is not in a particular order, okay?
Yes.
Yeah,
Yes.
you may be
But if you are, means if we have to perform an activities on data, then we have to perform all these activities.
Yeah, you may be performing any of these activities,
Yes.
depending on your data operation. So can you tell
Yes.
me what you understand when you say somebody tells you data has been analyzed? What are we trying to tell exactly?
Means sir, first we have to perform some actions on this data to get some result.
We are deriving some value.
Yes.
Okay,
Yes.
that let's say I have A and B. I want the addition of this value, or I want a count of this total A's in the value. So you're deriving something that is called analysis. Whenever you're
Yes.
doing analysis, you're actually, when you're looking at graphs and everything, bar chart and everything, you are actually seeing the result of an analysis, and that is what data analysis means. Okay.
Yes, sir.
Okay. So we'll go with Priscilla. Priscilla, what is data transformation do?
So after the data is analyzed, like once we have done the mathematical calculation, we actually try to transform the data.
No. Transform the data is usually done. Analysis is done on the clean data, means your data is clean by this stage now.
Yeah,
now you can
without the null values.
Yeah, null values, and data has been transformed already, data has been filtered already, data has been sorted already, data has been searched already. Analysis is the last thing happening. It is like finally the food is on the table. Now you can have it. It's like it's all set now. Now you do whatever you want to do, analysis, whatever information you want. You cannot gather information from a transformed data. Means the gathering of the information is done from the from the data that has to be analyzed. So we are trying to say analysis is analytical. When you say data has been analyzed, we are assuming that it is a clean data. All that work that you had to do, the extraction, pulling, that is already done. So transformation, can you read this slide and see what transformation is exactly doing? Okay.
So we are actually trying to create the output.
No, we are not trying to. If you see right hand side, what it is said, is it an output data or is it an input data?
Sorry, we are trying to create an input format.
So you are not even reached the stage of processing your data actually. In the previous case, what do you see in analysis? What are you seeing over here on the right hand side? It is Are you seeing what is there on the screen? When
yes, sir.
Data has been analyzed, you are getting the output. This is a desired output, right?
Yes, sir, after the calculation.
Yeah, means basically you want to find out something, and you don't have this data with you. You are applying some formulas and you're getting a value out of it. That is called analytical data. Okay. If you did not give this data in a correct input format, will you get the correct output? Tell me. Instead of 2, you type 3 over here. Will you get the correct output over here?
No.
Yeah. So that is what it means. So we are assuming this is a clean input data. Now, in order to create a clean input data, you need to make sure you have put it in a particular format. Now you're sending true, false or true. Maybe your program cannot read this. It wants to know the total ones in the column number 3. You're given true, false this. So you have to change the data. You have to change your input data even before it is given for analytical purpose. Even before you can create an output over here on the screen. Even before the data is analyzed, you need to make sure it is transformed in the desired input format. It is a transformed format. It is no longer that raw data that you gave initially. Are you getting it?
Yes, sir.
Now look at this second screen and tell me what transformation is happening over here.
So in input data, we are trying to assign one value as true, two value as false. So in the transformed input data, it actually shows that 1 is true, 2 is false, 4 is true.
No.
So actually what is happening is it's removing the first column of the alphabetical because we don't require it.
It is removing the first column. Rest of the records are same. There is no change in the record. Do you see any change in values over here? It is this column number 2 and this is column number 3. So before I send the data for analytical purpose to do, to calculate anything that you want or to want to derive something, I am giving it. I am not giving all the data. This input data must have come from somewhere. Somebody must have sent it to you. You must have stored it in some database or must have stored it in some files. But do you need all the data for your analysis purpose? No. You just require 2 columns, 1, 2, 4, and true, false, and true. After this transformation takes place, maybe you need to do one more transformation that true, false, and true is also not accepted. So you go back and you apply this second formula. We say if true, then change it to 1, and if false, then change it to 0. So transformation can be followed by a transformation process. Are you understanding what is the difference between analytical process and transformation process?
Yes, sir.
Okay. So Prajakta, can you explain what does data cleaning means?
Yes, sir. Means in data cleaning, we have to perform ETL. Means first we have to extract the data, then we have to transfer the data, and after transferring the data, we have to load the data. Means we have to store the data in somewhere.
Yeah, I mean that is a ETL process. I'm talking about
Yes,
what is
yes.
what do you mean by data is been cleaned? Yes, can see the screen.
Yes, sir.
Yeah, when you say cleaning the data, what are you actually doing?
Uh, means to getting the desired output, we have to perform some actions on this data.
Eh, Cleaning of the data
Uh,
means some data you have not sent correctly.
yes.
Okay, what is the problem in the left hand side data that you have received? Input data you have received. What is the problem?
For so in last column, for last column,
First row,
first row means
there is no
null values.
null value is sent. No, this is not accepted. It is not clean.
Yes.
My logic say if I want to derive now how many true values are there and how many false values are there, can I get it if the null values are passed?
No.
That
No.
is why even before it is transformed, you make sure it is clean.
Yes.
Some level of cleaning is required. This is
Yes.
also an example of transformation, you can say. But I am trying to help you distinguish, a finer distinguishing between what is
Yes, yes.
transformation, what is analytical, and what is clean. Okay.
Okay. Yes, sir.
Once you do this cleaning process, maybe you apply the transformation logic. Now you got A1 false, B2. Now the data is complete. It is clean. Data has to be complete as desired. That is what clean data would mean. Okay. Incomplete data is
Yes,
not
yes.
accepted. If you say I'm asking your name, you just cannot give me a name. Now you have to give me a full name also, right? That way. Once you clean, maybe
Okay,
you apply another logic to transform it. Maybe you're giving this transformation logic. If true, then change it to 1. If false, then change it to 0. But this may be operating on a cleansed input data. Correct?
Yes, sir.
If this data was not clean on the beginning, what is the use of transformation? You will still miss it. So cleaning is a different process. Transformation is a different process. Okay. So now tell me, Rasila, what is filtering data means, and what is sorting means, and what is searching means? What does filtering means?
So in filtering data, we are actually trying to filter, for example, here the value 1. So when we are trying to filter, so we have mentioned mentioned the query as select star from input data, where the column 2 is exactly, where the column 2 is equal to 1. So by shooting that query, it will actually give the values which has the it will give the data which has the value as 1.
Okay. So in a,
So others are not
so
shown.
when you're filtering the data, does the data set input data set already exist with you, or it doesn't, or it is something doesn't exist with you?
No, from the input data only we are trying to filter.
Yeah. So your input data is actually like your output data. Okay. This output data was created somehow, but based on this output data, this output data has become input to your filtering process now. So your input data can be actually an output of some other process also. All these processes that I'm talking about, they may be connected with each other in a pipeline also, right? So here you are filtering the data means I can again go back and filter on this particular data. Say I want this time column 2 equal to 2, means my data set is already existing with me when I want to filter it. Okay, my original data set is not gone, the output is still there with me. What is sorting and what is searching do exactly? What is the difference between searching and filtering?
So searching is like if we just enter a particular value, it will just search and give us. Filtering is like we are trying to apply a filter on that particular table.
The difference between now in the original filtering slide, the data was already existing. You see 1, 1, 2 over here and the same records over here. In this case, when you're searching, do you have that you are seeing 10, 20? Where it is? It is in some file over here, right? Some file on your
In a
database.
separate document.
Is it yeah, separate document itself? Is it there in the database? No, right? The output data you have created based on your search. Filtered data already exist. The input data already existed. You didn't have to search for it exactly. It is a simpler search operation. If you're actually searching the data, you might have to apply some indexing or use a binary tree algorithm, right? I explained you what is indexing and binary tree, right?
Yes, sir.
What is indexing do exactly? Why indexes help to search faster? Explain.
So indexing is like assigning a value.
Indexing is like you are storing the address of every record somewhere in a separate table.
Yeah.
That address can be a block address on a hard disk, or it can be a memory address called pointer. Even in the memory, if you want to search, if you know the address where it is located in the memory, you can simply go there and find the value, right? Correct? If you know the latitude, longitude, can you find a person wherever he is or she is? In GPS map, if I give you the latitude and longitude, you're wherever you are, can I come and find you easily?
No, sir. We need that particular location.
Correct. That is what I'm saying. So if you have that address, location, can I find you? Can I know what roads I have to catch, what buses I have to catch, how to come to your house? Is it possible? The data can I create a searched input data based on the location that you give me?
No.
I can. No, if you give me a latitude, longitude, I will be able to find out the Google Map directions and come to your house. No.
Okay, using the exact location. Okay.
Yeah, I have only the location with me. I don't have the road name. I don't have that data is not there with me. I have to create a data set out of it. Like in this case, P10, 8, A is 20 means the electricity bill of P is 10. Electricity bill of A is 20. It is there in the document. I had to do the process. Once you told me, I need to search all the electricity amount. So I was able to go in the document and search it and come up with a newer data set. If I want to come to your place, you have to just store the location in your database, but I don't have the roads and everything. That data set I will generate. So that is the difference between searching and filtering.
Okay, sir.
What is sorting does?
So sorting is like we can sort the values in ascending or descending order.
Right. And what is sorting? What is the use for sorting? Why do we sort data?
To reassign the indexes, sir?
No. Sorting is done so that we can, number one, you're getting more organized. That's what sorting does, right? Number two, it helps you in searching a particular record very fast. Will it be easier to search if everything was sorted out?
Yes, sir.
So sorting is used for faster searches. So it is not necessary data is been sorted in the database. No, when you're storing the database, is it sorted at any given time? It may not be indexed also. So definitely, so what you do, you go back and then index is like a sorted database. You can say it is sorted on that key. 1, 2, 3, 4. You saw that, no? The way index database looks like. So it is a sorted database. So definitely sorting is happening there also. But what if you don't have an index? You have the data set and you want to display it on your front end screen, and you want to show all the somebody saying show me all the Mumbai records, you show me all the Delhi records. So you have to sort it. So sorting helps you not to be organized, but also helps you if you sort the data, keep the sorted data, it helps you to retrieve the records very fast. Is it clear whatever I have explained?
Yes, sir.
Prajakta, any questions?
No, sir.
Okay. Was it very tough? I think we should just let me stop the recording. So now I don't want to go forward because it's becoming like too much of theory, no? It's not actually too much of theory.